Welcome back, everyone, for another deep dive. This time, we're exploring something that's probably right in front of you right now, but you probably never think about it.
And what would that be?
I'm talking about blow molding. I know it doesn't exactly sound exciting,
Yeah, not the most glamorous topic.
but trust me, this process is the unsung hero behind countless everyday objects.
Exactly. From the bottles we drink from to the fuel tanks in our cars, blow molding is quietly shaping our world.
And get this, even I was surprised by some of the things I learned while researching for this deep dive.
Oh, I bet. There's more to it than meets the eye.
There really is. So today we're going to unpack the secrets of blow molding using this excerpt from Blow Molding, a comprehensive overview.
Great source. It's packed with insights.
It really is. So let's jump right in. Can you walk us through the process? Like, how does blow molding actually work?
All right, so imagine you have a handful of those tiny plastic pellets.
Like the ones you see in those videos of factories.
Yep, those are the ones. So first, these pellets are melted down into a gooey liquid.
So they're heating it up until it's like molten plastic?
Exactly. And then this liquid is formed into a tube called a parison.
Kerosene. Okay, I'm taking notes. So that's our starting point.
You got it. Now, this parison is clamped inside a mold.
And that mold has the shape of whatever they're trying to make.
Precisely. So
Right.
now we have this warm, gooey tube of plastic trapped inside this mold. And here comes the fun part. Compressed air is blasted into the parison.
So it's like inflating a balloon inside a mold.
You're getting it.
Uh,
The air pushes the parison outward, causing it to expand and take the shape of the mold.
and as it cools down, it hardens into that shape.
Exactly. The mold opens up and boom, you have your finished product.
That's so cool. It seems so simple, yet so ingenious.
And the best part is you can use the same mold over and over again to make tons of identical products.
That's what makes it so efficient for mass production.
You nailed it. Think about how many plastic bottles are made every single day. Blow molding makes it all possible.
It's mind-blowing. But I have a question. If it's just air pressure pushing the plastic outward, wouldn't the walls be really thin?
That's a great question. And it's one of the things that surprised me too when I first learned about this. But actually, one of the key advantages of blow molding is that it allows for consistent wall thickness.
So even though it's hollow, it can still be strong and durable.
Exactly. You can have a lightweight bottle that can hold a liter of liquid without bursting.
That's incredible. And speaking of more than just bottles, the excerpt mentioned that blow molding can create some surprisingly complex shapes.
Oh, absolutely. It's not just for simple things like bottles. We're talking about car fuel tanks, industrial containers, even some toys.
Wait a minute, are you saying those intricate toys are made with blow molding?
Yep. And those complex shapes need to be strong and durable, which is where that consistent wall thickness we talked about comes in.
Wow. I never realized how much engineering goes into making something like a plastic fuel tank. But hold on, if it's such a complex shape, wouldn't it need multiple pieces? How do they get all those curves and details in one go?
Ah, that's where the design of the molds gets really interesting. The two halves of the mold can have all sorts of cavities, curves, and even undercuts to create those complex shapes.
So it's like a 3D puzzle where the mold pieces fit together to define the final shape?
You got it. And there's another key element we have to talk about: draft angles.
Draft angles.
Yeah, those are slight slopes that are incorporated into the design of the mold. You might not notice them, but they're crucial for getting the object out of the mold once it's cooled.
So without those angles, the plastic would just get stuck.
Exactly. Those draft angles ensure a clean release so the product doesn't get damaged and the mold can be used again.
It's amazing how every little detail plays such an important role. I'm already looking around my house and spotting all sorts of things that could be molded.
I bet you are. Once you know what to look for, you start seeing it everywhere. And it really makes you appreciate the thought and engineering that goes into these everyday objects.
It's like learning a secret language of manufacturing.
That's a great way to put it. Now I think it's time to dive into the pros and cons of blow molding. What do you think?
Let's do it. I'm eager to learn more about what makes this process so versatile and maybe even its Achilles heel.
All right, let's get into it.
Okay, so we've uncovered the magic behind blow molding, but I'm curious about the bigger picture. Why is this process so popular? What are the advantages?
Well, for starters, it's incredibly efficient. Like we talked about, you can use one mold to make thousands, even millions of identical products.
Right, that's what makes it so cost-effective. But it's not just about cranking out simple bottles, right? We talked about fuel tanks and toys, too.
You're right. Blow molding isn't limited to basic shapes. You can get pretty complex with it.
So how does it handle all those curves and intricate details, like those squeezable bottles with handles and textures?
It all comes down to the mold design and the type of plastic used. Remember those draft angles we talked about?
Yeah, those are important for releasing the object from the mold.
Exactly. They help prevent warping and damage, especially with complex shapes. And the plastic itself plays a big role too. Some plastics are more flexible, others are more rigid. It's about choosing the right material for the job.
So there's a lot more to it than just air and a mold. It's about material science and engineering too.
Absolutely. And let's not forget about those molds. They're like works of art themselves. Sometimes they have multiple parts that fit together with incredible precision.
Those molds really are the unsung heroes of blow molding.
I like that. Unsung heroes working behind the scenes to create all those cool shapes. And speaking of cool things, another advantage of blow molding is lightweight construction.
Right, lighter cars,
Mm.
better fuel efficiency. But how does it compare to other manufacturing processes in terms of weight?
It's very efficient because we're creating hollow objects. So we're using lac material compared to something like injection molding, which creates solid forms.
Makes sense. So blow molded products are naturally lighter.
Exactly.
Yeah.
And that has benefits beyond fuel efficiency. Think about packaging. Lighter packaging means lower shipping costs, which is good for the environment and the bottom line.
It's amazing how something like blow molding can have such a ripple effect on the entire supply chain. But I gotta ask, are there any downsides? It can't be all perfect, right?
Well, no process is perfect. One limitation is that it's mainly for hollow objects. You can't make solid, complex shapes like you can with injection molding.
So if I wanted to make a solid plastic toy with moving parts, blow molding wouldn't be the best choice.
You got it. Blow molding is specialized for hollow shapes with consistent wall thickness. And speaking of specialized, another downside is the initial investment.
Ah, so setting up a blow molding operation can be pricey.
That's right. Those molds can be expensive to design and manufacture, especially for complex designs.
Mm.
And you need the right machinery for the whole process.
So it's not exactly a DIY project for my garage, huh?
Probably not. It's better suited for large-scale production where the efficiency and cost savings in the long run outweigh those initial investments.
So it's all about finding the right tool for the job. It sounds like blow molding has a lot to offer, but it's not a one-size-fits-all solution.
Exactly. And what's really exciting is that the field is constantly evolving. There are always new innovations and techniques emerging.
Ooh, innovations. Tell me more. What's on the horizon for blow molding?
One of the most exciting areas is 3D blow molding.
3D blow molding. So that's like combining the traditional process with 3D printing.
Exactly. Instead of using those expensive metal molds, we can 3D print them.
Wow, so that would make it much faster and cheaper to create those complex molds.
It would. Plus, 3D printing allows for even more intricate designs. You can create bottles with personalized shapes, textures, even embedded logos.
So every bottle could be unique. That's pretty cool. But it's not just about aesthetics, right? What about functionality?
You're right. 3D blow molding can improve functionality too. Think about medical devices. We could create implants or drug delivery systems with complex internal structures, all thanks to the precision of 3D printed molds.
Wow, so we're talking about life-saving applications. That's incredible. It's like blow molding is merging with the medical field.
It really is. And another exciting development is in sustainable materials.
Yes. We touched on how blow molding is already fairly low waste, but using eco-friendly materials would be a game changer.
Absolutely. There's a growing trend towards using recycled plastics and bio-based polymers.
So instead of relying on virgin plastics, we can use materials that are better for the environment.
Exactly. It's all about creating a more circular economy where materials are reused and repurposed, and it's a win-win for businesses and the planet.
I agree. But are there any challenges in using these new materials in blow molding?
Well, some recycled plastics might not have the same properties as virgin plastics, so there's a learning curve in adapting the process. But the industry is making great strides, and I think we'll see more sustainable blow-molded products in the future.
That's great to hear. It's inspiring to see how this technology is evolving to become more sustainable. So what surprised you the most about blow molding?
For me, it was the level of innovation. I thought it was a pretty straightforward process, but there's so much more to it. The design complexity, the precision, the constant evolution, it's amazing.
I know. I came in thinking it was all about simple bottles, but it's so much more than that. It really makes you appreciate the ingenuity behind those everyday objects we take for granted.
It does. And I encourage everyone listening to take a look around and see how many blow-molded objects you can spot. You'll be surprised by how much you find.
I'm definitely going to do that. And a huge thanks to Blow Molding, a comprehensive overview for providing such a fascinating look into this hidden world.
Yes, great source. It's a great starting point for anyone who wants to learn more about blow molding.
It definitely is. And to our listeners, if this deep dive sparked your curiosity, don't stop here. Keep exploring, keep learning. There's a whole world of fascinating discoveries out there. Until next time.